So today we are going to be talking about logarithms and their properties. We need to first talk about why. Why in the world do we need logarithms? Well, logarithms and exponents are inverses of each other. That means that they're going to undo each other. We did this in our last class in 6.2. Do you remember what the first step in solving one of these problems is? It was to get the bases the same. Bases the same. Okay? And this one, we can. We would have 2x plus 1 and then 2 to the fourth power, right? And then we would just let the bases cancel each other out. But we have a problem because that was 6.2. This is 6.3. And in this one, we have a 5. There is no way to turn a 5 into a 2. It can't happen. You cannot get the bases the same. So we've got to figure out how to undo that exponent. That's the key, is to get that basically out of the exponent. Once it's down on the ground floor, we can work with it. But when it's in the exponent, we can't do anything. So the way we undo exponents is we do logarithms. We take a log. That's R, logarithm. So this section is designed to help you solve equations that have logs in them, but also it's going to help you solve really complex equations where you have the x in the exponent, but you cannot get the bases the same. Okay, so first let me show you the key. We're going to do some riding the roller coaster, okay? You need to be able to go from logs to exponential form and back. You need to be able to go back and forth. So what you're going to do is you're going to ride the roller coaster. So here's our roller coaster. It's going to always go through the base. Always start with the base. So that is the base of the log, that 5 right there. So go through the base, come around to the 2, and then come to the 25. So that means that log base 5 of 2 is 25. Let me do that again because we need to make sure that you understand that. So you're going to say 5 to the second power is 25. Okay? So you need to be able to go backwards where you can say log base 5 of 25 is 2. All right, so we're going to use that. So we're going to use our little, get on our roller coaster, and we're going to say log base 2 of 32 is 5. Log base 2 of 32 equals 5. We're just going to be writing an equivalent statement, okay? So we're going back and forth between exponential equations and logs. Let's do it again. Remember, we always start with the base. So you would have log of 2/3. So you can have a weird base like that. Log base 2/3 of 27/8 is -3. Let's keep going. Now we've got a log. So now our answer is going to be in exponents, in exponential form. So we'll say 4 to the -3 is 1/64. 4 to the -3 is 1/64. Do it again. Log base 3 of 2/3 is the cube root of 9. Log base 3 of 2/3 is the cube root of 9. So as long as you can do that roller coaster here, you'll be able to easily convert from logs to exponential form or from exponential form to logs. And of course that's a technique you need because we're going to be using it later on. Okay, now we have the special logarithms. Okay, so these, you may notice there is a log button on your calculator, and I did not bring my calculator home. But it says it's a log button on your calculator. Let me see if I turn this off. Is it still recording? Yay! Okay. All right, so the log button is on the left. I don't think I can draw on this. Nope. Okay, well, the log button is on the left about halfway down. Do you see that button? It is 1, 2, 3, 4, 5 from the bottom. Okay, and then underneath the log button is an LN button. So that's the two buttons we're going to be talking about. Okay, so let's go back. Okay, so the log means that it is in base. The base of every just plain log is base 10. It's called the common log. Log base 10 of x. So all you're going to do is you're going to put that, oh, that's just the log. Log base 10 of x is the log button on your calculator. So if you want to do the log of 3.5, it's really easy. You're just going to, let's see if I can pull that calculator back up. Yep. So you're going to have the log of 3.5. And there it is. 0.544. We'll just do, we'll go out to 4 decimals. 544, and that will be a 1. 0.5441. So 0.5441. And so because we're in the base 10 system, all our numbers are in base 10, that's why we have this common log button. Now there's another log that we take. It's log base E, because happens all the time in business and finance. So we're going to have log base E, and that is our LN button. That's called the natural log. One is the common log, one is the natural log. A lot of people just call it log and the LN. And we can do the same thing. The LN, the natural log of 5. I'm just going to get back to my calculator. Whoops, sorry. And so I'll do the same thing. I'll hit the little LN button of 5 and enter. 1.6094. 1.6094. All right. So we're going to be using those a lot. Common log, the log, and the LN, the natural log. Okay, so now we're going to use what we've just learned to solve some equations. That's why we learned them, right? We want to be able to solve these things. So first thing we're going to do, notice all these equations have logs in them. So we're going to first ride our little roller coaster. So we're going to have 3 to the x power equals 81. And remember, to do that, you just need to get your bases the same, right? So 3 to the x, and 81 is 3 to the 4th, I believe. Let me check it real quick. 3 raised to, I didn't bring my calculator home because I wasn't expecting us to be out of power. 3 to the 4th, I believe. Yeah. So that's 3 to the 4th. So my x is going to be equal to 4. So we just have to get our bases the same. Okay. Now this one is tricky a little bit, because when I start to come around here, I don't have anything, right? There's nothing sitting here. So I don't know what to put. But remember, if it's just a regular log and they don't put anything there, 10 is the understood base because we are in base 10. So 10 to the x equals 0.01. So again, we've got to put that in with like bases. Now, there's a couple different ways you can do this. I'm going to write this as 1 over 10s. This is in the hundreds place. 1 over 100. Remember, to 10 to the 10 to the second is going to be the hundreds. Okay, and then we talked last time, if it's on the bottom and you want it on the top, it's okay to move it. Okay, you just move it to the top, but remember you have to change your exponent to be negative. So now that our bases are the same, it's just like the game Tetris. The bottom falls out and we have x equals -2. Okay, let's work a couple more. All right, this one's interesting. We're going to have 3 to the second equals x minus 1. So this one, I don't have to get the bases the same because I can just say 3 to the second is 9, right? So 9 equals x minus 1, so my x is going to be 10. That was pretty easy. We're just going to keep on trucking. We just keep riding our roller coaster. X to the 4th equals 81. So once you get good at riding your roller coaster, these problems are really not that difficult. Okay, so now we have x to the 4th equals 81. Now we have already worked a problem like that. Notice this one over here. We already know that 3 to the 4th is 81. So, but we could still show our steps. So that's going to be 3 to the 4th is 81. X to the 4th is 81. So my x is equal to 3. So in that case, the bottoms can't drop out because they weren't the same. But that was our x. That's how we've determined our x. Let's do just a few more. 10 to the x power is 0.001. That's very similar to this one that we did up here, right? Except I actually put the 10 in there that time. So we'll have 10 to the x is equal to 1 over, let's see, we've got our tens place, our hundreds place, and now we're in our thousands place. So that's going to be 10 to the x is 1 over 10 to the 3rd. And the easy thing to remember there is just count your zeros. That's what your exponent's going to be. Okay? And then I want it to be up top. So we can move it up top. We just have to make it a negative. So my x is negative 3. Let's see. I'm just going to keep working. We'll work all of these. 3 to the x is equal to 1/3. Once again, I want that 3 on the top. It's got to be the base, right? So I'm going to put it on the top, and that means once I put it on the top, I take the exponent and make it negative. Now, I didn't have an exponent here, but if you don't, that's just a 1. So when I put it on top, I'll make it negative 1. So x is negative 1. This one's a little bit trickier. 6 to the x equals the square root of 6, because you have to remember what we did last time when we talked about when you have an index there and I have a power here. I didn't really have an exponent there, right? So I just put a 1 there. So 6 to the x power is going to be 6 to the 1/2. Just remember that the root, the square root, roots of trees are on the bottom, except for days like today when it's really windy, and hopefully the roots will stay underground and not topple the tree. Anyway, so we're going to get x equals 1/2. Let's keep on trucking. So 3 to the x is equal to 27 to the 3/2. Now remember, once again, here's my base is 3, so I just need to write that 27 as 3 to some power. And in this case, I can. So that's going to give me what? 3 to the 3rd. That would be that 27 is 3 to the 3rd. And that gives me 3/2. Now, my bases cancel, so the 3's on the bottom are gone. So I get x equals 3 times 3/2. Because remember, that's a peeping Tom. That 3/2 is a peeping Tom, so we're just going to multiply them together. So that's going to give me what, 9/2? So I can just leave that. X equals 9/2. I don't have to write it 4.5. 2 more. X to the 6th is equal to 25. How are we going to do that? Oh, I should say, instead of 25, I'm sorry, x to the 6th equals 5 to the 2nd. All right, so there's a trick to this one. And I forgot what the trick was. I don't have my notes with me at home. So I'm going to come back to that one because I can't remember what the trick is, and I don't want to waste y'all's time while I try and search through the recesses of my mind and figure it out. So let's do another one. 4 to the 1/6 to the negative 1/6 is equal to x. Oops. Is that right? Okay. So we just have to figure out what 4 to the minus 1/6 is, right? So there's a couple of different ways we could do that. First thing is I'm going to rewrite that 4 because I don't know what the 6th root of 4 is. So I'm going to use my exponents, okay? So this is sort of a trick as well. I'm going to rewrite that 4 as 2 to the 2nd. Why? Because I can. Okay? I can. And then I have an exponent to work with my little, have an exponent to go with my negative 1/6, right? So now I can multiply these. I got to multiply these guys together, right? So I'm going to multiply those guys together. So that's going to be 2 to the, let's see, 2 times minus 1/6. So that's going to go in there 3 times. Minus 1/3. All right, so 4 to the minus 1/6 is the same as 2 to the minus 1/3. Now I'm going to put that 2 on the bottom. Make our homesick exponent happy now. Okay, and what is the third root? What is 1/3? I just told you it's the third root. So that's 1 over the third root of 2. So you can plug that in your calculator. We don't like to have a cube root or a square root on the bottom, but they're not as picky in this section. So you could just plug that in your calculator, or you could leave it like that. The back of the book might actually let you leave it like this. All right. Let's do the properties of logs now, okay? So our properties of logs are laws. You know, there's things that you've just got to remember, but they're actually really, really easy, okay? So let's go down to these right here, the 5 to the 0 power and the 7 to the 0, 32 to the 0. What are all those equal to? You remember, anything to the 0 power is 1, right? So if I do this, if I do my little roller coaster, I'm going to have a to something equals 1. Okay, because I don't know what that is. A to something equals 1. Well, remember, anything to the 0 power is going to equal 1. So a to the 0 would equal 1. So that means that question mark is going to be a 0. Okay, so basically anytime you see a log and you have a 1 there, you know that it's going to be 0. Log base anything of 1 is going to be equal 0. Now look at this one. Notice we've seen these guys before. 2 to something equals 2 to the third. Well, that something, that question mark is going to have to be 3, right? And then 11 to something equals 11 to the 6th. So that something is going to have to be 6. So a to the something equals a to the x. What would that something have to be? That something would have to be my x, right? Okay, so when I do my roller coaster, I'm going to have a to the something equals a to the x. So I know that this is going to be x. Okay, notice here is the base of my logarithm, and this is the base of my exponent. So I have 2 bases, and they are the same. So when the bases are the same, the exponent is now on the ground. Isn't that cool? That's our mathematical magic. So if your bases are the same, they cancel out. Just like when I had this when I had 2 to the x equals 2 to the third. These bases are the same. They cancel out, and I get x equals 3. So it's the same thing here. These bases are going to cancel out, and I get just what's up there on top. Okay? Now, look at this one. This one's a little bit weird, but this is the base. This is the whole exponent, okay? But look, the base of the log and the base of the exponent are the same. So once again, those are going to cancel out, and you'll just have x left over. So it's mathematical magic again. We can get, in that case, we got rid of the exponent as well as the log, all in one fatal swoop, okay? So now we're going to simplify these logs, and we don't need a calculator at all to do these because, see, my bases right here are the same, the base of the log and the base of the exponent. So since those are the same, these guys are going to cancel out, and I'm just going to have my 7 left over. So those are gone, and I just have a 7. Now, remember we said if I have a 1 sitting here, do you remember what the answer has to be? It doesn't matter what the log is. Anything to the 0 power is going to be equal 1. All right, now look at this one. I have a base of 4, and now I've got the base of the log is 4. So I have my 2 bases. Those cancel out, and my answer is just 21. I don't have to do, that 2 doesn't look like a 2. 21. So I don't have to do anything else. Now this one, this is ln. What is that? Remember that's log base e of 1. So remember we said anything, it doesn't matter what the base is, anything where you're taking the log or the natural log of 1 is going to be 0, just like b was up here. It's the same thing. It's just now that's log base e. It's the same thing though. Now this one is a little bit tricky because you have, remember with let's look at this one. Yeah, look at the first one. With this one, I had the log, the base of the log, the base of the log and the base of the exponent were the same. But here, I don't have a base of a log. I don't have a number here. Do you remember what you put when you don't have a number there? We are in the base 10 system, so we're going to put a 10 there. Now, notice my bases are the same, so they just cancel out. So they just cancel out, and my answer is going to be -5. Okay, all of those we were able to do just because of these properties of logs, and we didn't need a calculator for it. Now, this says to evaluate without a calculator. So we must still be using these same properties of logs. So my property, remember, if I don't have a number under the log, that means it's a base 10. So once again, those guys are going to cancel out, and my answer is just going to be 4.3, sorry. The natural log, remember, this natural log is the same as log base e. Okay, so that's going to be the same thing. So that will be e to the 2.7. Once again, my e's, because 1 is the base of the log, 1 is the base of the exponent, those bases cancel out, and my answer is just going to be 2.6. Okay, so those are pretty easy. This one is a little more interesting because I have that square root of 2. So let's put the square root of 2, and that's going to be times the natural log. Remember, it just means it's got a base of e. So those bases are going to cancel out, and this would be my answer, right? That one would be my answer to that. So the answer to this is just the square root of 2. Well, the square root of 2 times the square root of 2 is the square root of 4, which is just 2. So the answer to that whole problem is just 2. Now this one, it says evaluate with a calculator. And the reason you have to evaluate it with a calculator is because you can't without, okay? This is log base 10, and I can't write that as 10 to some power, okay? So I'm going to have to use my calculator. So the log base 10 of 1247. So I'm just going to plug that in my calculator. Log of 1247. And that's and I usually go out to 4 decimal places. 3.0959. All right. So we'll just write that down. If it'll let me. 3.0959. I think that's what I said. Same thing with this one. I cannot write this as e to some number. Okay, so I've got to use a calculator. So the ln of 0.014, the ln 0.014, negative, so we can have a negative number, negative 42689. Oh, excuse me, 2687. 2687. Oops. Negative 42687. So those are pretty easy. You just plug them in your calculator. Okay. I'm going to take a break, and then we will come and finish the rest of this section.